So this is 9.5 part 1. So in the past, we've talked about points as XY points on our coordinate plane here. But now we're going to talk about polar coordinate systems. So our graph looks like this for a polar system, where this point here is the pole. That's kind of where we start. And then 0 is here. What does this graph kind of look like? The unit circle. We're bringing back the unit circle. So in our polar coordinate system, the origin is called the pole. And then we're going to be dealing with points that are, instead of x, y, it's going to be r, comma, theta, where r is talking about the distance and theta is the angle. And then just like in our unit circle, our directed angle can be positive, but it can also be negative. So if we had a negative angle, we would go down, similar to how we did in the unit circle. So the next page just talks about the same thing. Each point in the plane can be assigned polar coordinates r, comma, theta, where r is the directed distance from O, which O we said is the origin, to P, which is the point that we're talking about. And theta is the directed angle, which is counterclockwise from the polar axis to segment OP. So we go counterclockwise when we go in the positive direction, but then we would go clockwise in the negative direction. All right, so example 1a. We have to plot the point 2, comma, pi over 3. So what we're going to do is go to pi over 3 on our unit circle looking like thing here. So we have pi over 3 there. And then for 2, we're going to go 2 spaces away from the pole. So if our pole is here, 2 spaces, so 2 rings in our circle. This would be 1, this would be 2. So our point would be here. The cool thing about polar coordinates is that this point here, so point, we'll call it point P, it can have different coordinates but still be the same point. So with polar coordinates, kind of just like our unit circle, you could go all the way around and go back to that. So we could say pi over 3 plus 2 pi. So it could be 2 comma, what would pi over 3 plus 2 pi be? We need a common denominator. We would make this 6, so 7 pi over 3. So these are the same. We could also go in the negative direction. So starting here, if we went in the negative direction around to here. So we could also subtract 2 pi to find what the negative point would that be. So pi over 3 minus 2 pi, we'd make it 6 pi over 3. So this would be 2 comma negative pi over 3. Negative 5 pi over 3. There. So that would also be the same point. It would fall on that same point P, but we're just going in the negative direction instead. There's also one other way that we could do that, is our polar axis. We were just looking at pi over 3, but if we extended it all the way down, so all the way straight across, we could say that we're going to 4 pi over 3, but instead of going in the positive direction 2, so instead of going this way 2, we can go negative 2, which just means we go in the opposite direction. So if we had 4 pi over 3 and 2 as our polar coordinates, instead of going positive 2 this way, we would say negative 2 to go in the opposite direction. So another point that is the same thing would be negative 2 comma 4 pi over 3. So all 4 of these are actually the same point. I watched Miss Boyd's video on this yesterday, and she just talks about how much she loves polar coordinates because you can name the same point with like a whole bunch of different coordinates versus like rectangular. If we had just a point here, like this point would just be 2, 2. You can't name it anything else to get that same point. So that's what's cool about polar coordinates. So let's do the next one. We have to plot the point 3, negative pi over 6. So we want to go negative pi over 6. So one way that we used negative in radians, I guess, was we can either convert it to degrees and see how many degrees we would need to go that way, or you could count positive pi over 6. I'm going up 2 spaces, so a negative pi over 6, I would have to go down 2 spaces. So this point here would be negative pi over 6. And then the point is 3. So on negative pi over 6, I want to go out 3 rings. So I start at the pole and go 1, 2, 3. So that would be my point. Well, if it was negative 3, we'd go 3 in the opposite. Well, because this is negative, we know that pi over 6 is this much, so I would have to go that much in the negative direction. If my point was negative 2 pi, I would figure out how much positive 2 pi is and then go in the opposite direction that much. What would be another polar coordinate that would give me this same point? So you could say, if we extended this out, that would be 5 pi over 6. And negative 3, perfect, or negative 3, 5 pi over 6. What else? So what's an obvious one? What does this point fall on in the positive? 11 pi over 6. So we could say positive 3, 11 pi over 6. Awesome. So all 3 of these are the same thing. So on our next slide, it actually talks about rules on how we can mathematically come up with other points that are the same as the first point we have. So if we had r theta, if we keep r the same, so like in that last example, r was 3. If we keep r the same as 3, you can just keep adding 2 pi to your theta to get the same point. If you change the sign of r, so if you change r to be the opposite sign, then you can add just a single pi. So this next slide just kind of rewrites it a little bit better. So if we have r, where r is the same, you can add or subtract however many even amounts of pi's. If you change the sign of r, so here if you have the opposite sign, you can add or subtract an odd amount of pi's. So if I had a point 4, comma pi over 3, and I said find 3 other points that are the same thing, what else would be the same? What would I have to do? So if I said 4, what would I have to do to find a point that would fall on the same point? Add 2 pi. So we can add 2 pi So that would be 7 pi over 3. We could also subtract 2 pi. We could also add or subtract 4 pi. You could add or subtract 6 pi. Any even amount of pi's. But if we change the sign, let's say this was -4. Here we would add or subtract an odd amount of pi's. So I would say pi over 3 plus pi, plus or minus pi, plus or minus 3 pi, plus or minus 5 pi. And that'll keep giving me the same value. So these would be the same as the one that we started with, both of these, whether it's negative or positive. But if you change the sign and make it negative, you're only adding an odd amount of pi's, adding or subtracting. So example 2, we want to plot the point 3, -3 pi over 4. So first thing we want to do is find out where -3 pi over 4 is. So 3 pi over 4 would be over here. So I would go in the negative direction to here. So instead of going around this way, 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, I'm going in the negative direction, 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. And then we want to go out to what number of ring? 3. So 1, 2, 3. So we're talking about this point here, the blue point. So we plotted the point, that's the first step. Then we have to find 3 additional polar points that are the same as this point, but it has to be in between -2 pi and +2 pi. So we just can't keep adding 2 pi because that would be outside of our domain here, outside of our restrictions. So we were given 3, -3 pi over 4. What would be another point? Awesome. The obvious one, that's the one in the positive direction, right there. It would be 5 pi over 4. Perfect. It's probably the easiest one to find. What would be another point that would be the same thing? Awesome. -3 pi over 4. Perfect. Because we would go pi over 4 here, but instead go in the opposite direction. So that falls on the same point. And then anything else? Let's see if we can find it mathematically. What if we keep 3 the same, what would we have to add to -3 pi over 4 to find the next one? 2 pi. So if I add 2 pi, we would change this to be 8 pi over 4. So this would be 5 pi over 4, which is what we already have. Can I add another 2 pi to it? So let's say if I added 4 pi instead. If we keep 3 the same and add 4 pi. Could I do this? Why not? Because it's going to be outside of our restriction. If we add more than 2 pi, we're going to be too much, too many. So let's change the sign. Let's change it to -3. If I change the sign to -3, what would I have to add to -3 pi over 4? Pi. I add an odd amount of pi, so I can add pi. So this would be, I think the one that we just found also, it would be 4 pi over 4, so -3. -3 pi over 4, which is also the one that we already have. But what else could I add or subtract? So again, if we change the sign, change it to -3, what else could I add or subtract to still be within that domain window? I could add 3 pi, let's try. to make this 12 pi over 4. When we subtract, we get negative 3. So it'd be 9 pi over 4. Is 9 pi over 4 more than 2 pi? Yes, so that is outside of our domain, so it doesn't work. So adding 3 pi, although it's a good idea, we could do that, but it's outside of our domain, so not quite. What else could we do? Subtract pi. So we could subtract, make this 4 over 4 pi. This would be negative 3, negative 7 pi over 4, which is within our domain. If we go negative 7 pi over 4, we're going around all the way this way, the negative direction to here, and then we would go in the negative direction backwards 3. So that would be the same point, negative 3 pi, negative 3, negative 7 pi over 4. So these would be 3 other points. So it's a little bit trickier to find other points when it restricts you, but still possible. You can just add or subtract 2 pi or increments of 2 pi. Or if you change the sign, if you flip it to the opposite sign, you can add or subtract increments of odd pi's. So 1 pi, 3 pi, 5 pi.